Hi students, this is Mr. Yao. In this lesson, we are going to talk about 4.7a, where we will learn to solve a quadratic equation by using the quadratic formula. Knowledge first. We are going to get answers that are similar to these, and we need to know how to simplify these, because a lot of you, when you see questions like these, you start simplifying just by, oh, you see a -6/3, and you're just going to get rid of that, and doesn't do anything with the other parts. So a better way is to separate the fractions, but of course we're going to simplify the radicals first. Square root of 162 can be simplified to be 9 square root of 2. So now when we actually try to simplify this, we are going to separate the fractions because this denominator is basically a common denominator between the two separate fractions. So here you go. It's going to give us -6/3 minus 9 square root of 2 over 3, which is going to become -2 minus 3 square root of 2. Question B. First, let's simplify the radical, and that is going to become 6 square root of 3. -10 over 8 minus 6 square root of 3 over 8. -10 over 8 is -5 over 4, and -6 over 8 is a -3 square root of 3 over 4. Next, simplify that first. That is going to be 5i square root of 3. So it's -15 over 10 minus 5i square root of 3 over 10. -15 over 10 is a -3/2. And then 5 over 10 is a 1/2. So we have a 1i square root of 3 on the top, which is just a square root of 3i. And we can typically keep the I on the end because that looks like a standard form from complex number. Now let's get into today's lesson. We have already learned completing the square from the previous lesson. Quadratic formula actually comes from completing the square. The quadratic formula is an end product from completing the square. It can help us find the roots of quadratic equation that won't factor. It's handy enough that we can actually use it to solve any quadratic we'll ever encounter. Before we can use the quadratic formula, because it has a very specific format, we actually need to put the quadratic equation into standard form, and that is ax squared plus bx plus c, which looks similar to what we had in completing the square. Try completing the square with standard form. Well, because the formula comes from completing the square. Even though the formula might be an easier way to do it, we still have to remember that the technique of completing the square. So let's go through that to actually find the quadratic formula. Ax squared plus bx plus c equals 0. When we want to complete the square, I did make a little mistake right here. There shouldn't be that over a, because the first step is to divide everything by a. So we only have this x squared in the front, and we do not need to worry about it when we try to complete the square. So after that, we're going to need to move the number over. So we'll have x squared plus b over a, x, and then plus space, because when we move the c over a over, it's going to become a -c over a. But in order to have the perfect square, we need to find out what exactly is going to go into this space so that we can complete the square. Next step, we're going to take the middle, because again, this is the formula we have been using, 2pq plus q squared, and that equals p plus q squared. So now p is already the x, and we need to find a q to be able to know what is q squared. So we're going to need to take that middle, b over a divided by 2. That is going to be b over -a. But then we need to square it. b over 2a squared is going to be b squared over 4a squared. And that is what we actually need to put into the space, because this is basically our q from the formula, and this is going to be our q squared. So we're going to need to put it into the space. We'll have x squared plus b over a x plus b squared over 4a squared. That equals to -c over a plus b squared over 4a squared. Next, after we found what we need to complete a square, well, now we actually need to have the square. So it's going to be x, and it's going to be this number that we already had right here, because that is our q, and that is going to go into the parentheses. So plus b over 2a, and then squared, which equals to the right side let's think about it. Let's say you have a question that is 3, 4 plus 7 over 16. In order for you to deal with it, you need to find a common denominator, and the common denominator is actually a 16. And in order to get the 4 to a 16, you need to multiply the top and the bottom by a 4 to get a 12 over 16. Then you can add. So this is the same situation. You have an a and a 4a squared. A can go into 4a squared, which means the 4a squared is going to be our common denominator. And that a, in order to get to 4a squared, need to multiply by a 4a. So we need to do it to the top and the bottom. On the top, negative c times 4a is going to give us a negative 4ac. And then over 4a squared, we also have this b squared on the back. Last step, we're going to need to square root it so that we can actually get the answer. And when we have a fraction, we typically square root it on the top and the bottom separately. Don't forget the plus minus when you take the square root. We have x plus b over 2a, that equals 2 plus minus b squared minus 4ac. Is just a better habit. I mean, well, we have a negative sign in the front, so we can avoid that, move the b squared in the front. Bottom, square root of 4a squared is just 2a. And now we got x almost being by itself. All we need to do lastly is just move that over to the right side. And that would give us the quadratic formula. But before we get to that, you may notice both fractions have 2a as the denominator. That's why you can actually combine them. So here is the quadratic formula. X equals negative b plus minus square root of b squared minus 4ac all over 2a. Now, this still looks like a very complicated formula, which is why there's this video that you can find. It can actually put a rhythm onto this formula, and it's going to make this formula a lot easier to actually remember. So there you go. Now let's move on to see how we can use the formula to solve a quadratic equation. Here's a quadratic equation. But since we need to use the quadratic formula, which involves a, b, and c, we of course have to make sure everything is in that format, which is standard form. So first step, we're going to need to put the equation in standard form, ax squared plus bx plus c equals 0. And in order to use the quadratic formula, we are going to need to identify a, identify b, and identify c. A is the number in front of x squared, in this case is a 1. B is the number in front of x, which is a 5. C is a number that's on the end by itself, which is a negative 4. You can actually directly use the formula to already find the answer, but in the next lesson, we're going to talk about something pretty specific. Let me write the formula on the top again. X equals negative b plus minus square root of b squared minus 4ac all over 2a. There's something special about this under the square root, this b squared minus 4ac. That basically helps us to decide what kind of answers we may get before we even finish solving it. So we're going to add an extra step. We're going to identify that first, and that is called the discriminant, b squared minus 4ac. We are going to find out what is b squared minus 4ac, the discriminant. Typically, we use a little triangle to represent discriminants, which is called delta, b squared minus 4ac. My b squared is a 5, and it's a good habit to put it inside parentheses because sometimes we may square a negative number, and that's more important to actually keep it inside parentheses. Minus 4 times my a is a 1, my c is a negative 4. I'm going to get a 25. Negative 4 times 1 is negative 4 times negative 4 is a positive 16. It's a 41. Again, this number, we're going to use it in the next lesson to understand how we can use it to identify what type of answers we may get. Now we can actually use the quadratic formula. We already found out this is going to be the number under the square root, so we just need to set up everything else. Negative b, my b is a 5, so we're going to be a negative 5, plus minus b squared minus 4ac, we already found it's going to be a 41, so it's square root of 41, and the whole thing all over 2a, my a is a 1, so it's 2 times 1, which is a 2. And lastly, remember to simplify your answers. So it's a good habit to actually separate the fractions to simplify to make sure you do it correctly. It's going to be a negative 5 over 2 plus minus square root of 41 over 2. Some questions may ask you to write the answers separately. Well, then you have the first one being negative 5 over 2 minus square root of 41 over 2. And the second one being negative 5 over 2 plus square root of 41 over 2. And if they ask you to write the smaller number first, well, the subtraction one is of course going to be smaller. So there you go. These are the two answers. Now let's move on to more examples. Number 1, identify A is 1, B is a negative 2, C is a negative 24. Let's still find the discriminant first before I actually get into the quadratic formula. And besides, as when you find this, you can put that number directly into under the square root. Okay, b squared minus 4ac. B squared is, you see b squared is a negative 2, so make sure you put negative 2 inside parentheses. Square it, minus 4 times my a is a 1, my c is a negative 24. We will get a 4. Negative 4 times a negative 24 is a plus 96, which is 100. Now let's find the answer. Negative b, my b is a negative 2, so it's going to be a negative 2 plus minus square root of 100 all over 2 times 1. So negative a negative 2 is a positive 2 plus minus square root of 100 is a 10 all over 2. I have two separate answers. One is going to be the minus. 2 minus 10 is a negative 8 over 2 is a negative 4. And the other is going to be the positive. So 2 plus 10 over 2 is going to be a 12 over 2, which is a 6. Number 2. First, we gotta make sure to put everything in the correct order in standard form before we start identifying A, B, and C. So m squared plus 4m, move the 20 over, minus 20 equals 0. A is a 1, B is a 4, C is a negative 20. The discriminant is b squared minus 4ac, which is 4 squared minus 4 times 1 times negative 20. That is going to be 16. 4 times negative 20 is a negative 80, but it's subtracting, so it's a plus 80, which is a 96. X equals negative b is a negative 4 plus minus square root of 96. We already found what's going to be under the square root. And lastly, all over 2 times 1. Let's simplify. Square root of 96. That is 16 times 6, so it's going to be a 4 square root of 6 all over 2. Let's separate them to simplify, but don't forget it's plus minus. So we'll get a negative 4 over 2 is a negative 2, and then plus minus 4 over 2 is a 2 square root of 6. And you can keep them separately, which is negative 2 minus 2 square root of 6 and negative 2 plus 2 square root of 6. Moving on, here's example 3. A is 1. Well, it's already in standard form. X squared in the front, x in the middle, number on the back. So A is 2, B is negative 2, and C is negative 15. Discriminant is b squared, so negative 2 squared minus 4 times my A is a 2, my C is a negative 15. I have a 4 in the front. Negative 4 times 2 is a negative 8, times negative 15 is a positive 120. Add together. It's a positive 124. X equals negative b plus minus square root of 124 all over 2a, so 2 times 2. Going, negative 2 is a positive 2 plus minus. Square root of 124 can be simplified as 2 square root of 31 all over 4. X could be, separate them. 2 over 4 is a 1/2, then plus minus 2 over another 4 is a 1/2, but on top is actually a square root of 31 over 2. There you go. That's example 3. Example 4, we need to move the 7 over. 5x squared minus 7x minus 7 equals 0. A is a 5, B is a negative 7, and C is a negative 7 as well. Find the discriminant first. B squared is a negative 7 squared minus 4. My A is a 5. My C is a negative 7. Negative 7 squared is a 49. Negative 4 times 5 is a negative 20. Times a negative 7 is a positive 140. Altogether, 189. X equals negative b, so it's a negative of negative 7 plus minus square root of 189 all over 2 times 5. It's going to be a positive 7 in the front plus minus Square root of 189 is that's actually a 9 times 21. So we'll have a 3 square root of 21 all over 10. By looking at this and think about it, 7 over 10 can be simplified, 3 over 10 can't be simplified. So you can choose to keep them that way. That totally works. Or you can choose to keep them as 7 over 10 plus minus 3 square root of 21 over 10. That works as well. Or you can even separate the plus and the minus into two different answers. That is example 4. Moving on, example 5. Okay, x squared in the front, which is gonna give us the a, which is a 2. B is with the x, so it's a 14. C, oh well, we don't have a c because we don't have a number on the end. That just means c is a 0. Discriminant is going to be 14 squared because it's b squared minus 4. A is a 2, c is a 0. So basically is 14 squared minus 0, which is 196. X equals negative b is a negative 14 plus minus square root of is 196 all over 2 times 2. Okay, we get a negative 14 plus minus square root of 196 to 14 all over 4. Two separate answers. First one is a negative 14 minus 14, then divided by 4. That's a negative 28 over 4 is a negative 7. The other one is a negative 14 plus 14 over 4, which is a 0 over 4. That's going to be a 0. So see, for this question, if you quickly notice, it's going to be a 2x, and then times x plus 7 equals 0. You're going to get a 0 and a negative 7. So factoring is still faster, at least for this question, compared to the quadratic formula. So it's still better to actually use the more proper method for each of the question. Example 6. Well, we're going to move everything to the left to make sure the right side is a 0. So we're going to add 7x squared and subtract 2. Add 7x squared, subtract 2. We'll get a 2x squared minus 3x minus 54. That equals to 0. Let's identify. A is a 1, not 1. A is a 2, B is a negative 3, and C is a negative 54. My discriminant is a negative 3 squared minus 4 times my A is going to be a 2. My C is going to be a negative 54. So I'll have a 9. And then it's a negative 4 times 2 is a negative 8. And then multiply with a negative 54 is going to be a positive 432. Together, 441. Okay, and now I can actually set up my using the quadratic formula. X equals negative b is a negative of negative 3 plus minus square root of 441 all over 2a, which is a 2 times 2. That is going to be a positive 3 plus minus square root of 441 is actually going to be 21 all over 4. Two separate answers. 3 minus 21 over 4 is a negative 18 over 4, which is a negative 9 over 2. And the other answer is going to be the positive 3 plus 21 over 4, which is 24 over 4. That is going to be a 6. That is everything for this lesson. And we will learn more about quadratic formula and the special situations based on the discriminant in the next lesson. Thank you.